Congratulations for sticking it out to the last lesson of the course. If you're here joining and watching this video today, thank you for sticking to the end. We are going to finish up section 6.6, which we started yesterday with tangent lines and velocities. So we're going to talk about how we can apply what we learned yesterday to some real life situations. And then tomorrow you'll have some kind of activity-based thing that will be due on Friday, and that will be the end of the course. So speed is the distance traveled divided by the time it took to cover that distance. Velocity is a speed with the added dimension of direction. You can calculate it using the same approach as finding average speed. So the average velocity is a change in the distance over the change in the time. So for example 1, we've got the distance in miles that a runner competing in the Boston Marathon has traveled after a certain time in t and hours can be found by this function. What was the runner's average velocity between the second and third hour? So t is 2 and t is 3. We know the average velocity, so we're going to figure out the change in distance over the change in time. So we're going to take this function f of 2, negative 1.3, 2 squared plus 12 times 2, and then we're going to do the function f of 3, negative 1.3, 3 squared plus 12 times 3. And if we simplify these on this one, we'd get, this comes out to be 18.8, and this one comes out to be 24.3. And so we're going to do the change in distance, which would be 24.3 minus 18.8. over the change in time, 3 hours minus 2 hours, which gives me 5.5. So the average velocity of the runner during the third hour, from hour 2 to hour 3, was 5.5 miles per hour forward. They're going forward and towards the finish line. Okay. So the average velocity, again, between these 2 points, same idea. They gave you the coordinates here, so you're finding what we would do is find the slope. Okay. So then the next one, instantaneous velocity. The velocity of the speed of the runner achieved at a specific point in time using the instantaneous rate of change. So we're using the function from yesterday. Okay. So baseball is dropped from the top of a 2,000-foot building. Top of a building 2,000 feet above the ground. The height of the baseball in feet after t seconds is given by this formula. Find the instantaneous velocity after 5 seconds. So exactly what is the velocity at exactly 5 seconds? So we're going to use our formula. We're going to replace the t with 5. So we're going to say v5 equals a limit as h approaches 0 of f of 5 plus h minus f of 5 divided by h. And now we're going to take and plug into this function. So we have 2,000 minus 16 times 5 plus h squared minus, and then 2,000 minus 16 times 5 squared. So this is the function with f or 5 plus h, and then the function with just 5. And that whole thing is over h. So if I simplify this, we have 2,000 minus, if I do this out, I'd have h squared plus 10h plus 25. And multiply that by 16. So 16h squared. And then 16 times 10 is plus 160h. And 16 times 25 is... Sorry, I lost track of where I was. 16 times 25. So 4 times 25 is 100. Times 4 would be 400. And then minus, and then if we simplify this inside here, we'd have 2,000 minus 16 times 25, which we just did, 400. So that would be 1,600. So if we simplify that, 2,000 minus 16h squared minus 160h minus 400 minus 1,600, and then remember this is all over h. The 2,000 will go answer with the minus 400 minus 1,600, And then we divide by h, so we get negative 16h minus 160. Okay, and then remember it's as h approaches 0, so we're going to replace the 0 for h, and we get negative 160. So what is the velocity? Negative 160 feet per second. So at 5 seconds time, the ball is traveling at 160 feet per second, and it's negative because it's going down. So this is how you're going to apply what we were learning yesterday. So we drop a ball and we're trying to figure out at that specific moment, what is the velocity the ball is traveling at. At 5 seconds, it's going exactly 160 feet per second, and it's going in the downward direction, which is why we see the negative. Okay, so then what about instantaneous velocity of an object at any time? So here we're going to go and do another one, same idea here. So we have a distance a particle moves along a path is given by this formula. T is given in seconds, and the distance of the particle from its starting point is given in centimeters. Find the equation for instantaneous velocity at any time. So now we don't have any specific time, we're doing any time. So plugging into the original formula, v of t equals the limit as h approaches 0. We're going to replace this function, so equals 18, and then t plus h minus 3 times t plus h to the third minus 1. So that's the first part of the function. So I'm going to put brackets around each part. And then the second part is just the function as it is, which is 18t minus 3t cubed minus 1. And then that whole thing is over h. So now we ought to simplify. So I'm going to distribute here, get 18t plus 18h. And then I have minus 3, and then I'm going to put in parentheses. If I do this part out, this is a binomial cube, so we got 1, 3, 3, 1, t to the third, t to the second, t, and then we have h to the second, h to the third. And all of that is positive because it had a plus. And then we have the minus 1, and then over here I'm going to distribute the negative sign. So I have minus 18t plus 3t cubed, and then negative and negative plus 1. And then I got to distribute this 3 out so we can have all our terms all set. So 18t plus 18h minus 3t cubed minus 9t squared h minus 9th squared minus 3h cubed minus 1 minus 18t plus 3t cubed plus 1, and that whole thing is over h. So it's a lot of algebraic work. If you're really careful, you should be able to get that done. And now we're going to find our terms we can cancel. So the 18t here and the negative 18t cancel. The negative 3t cubed and the 3t cubed. The negative 1 and the 1. I think that's it. So now we're going to divide everything else by h. So 18h divided by h is 18. And then negative 9t squared, the h's cancel, so that term's all set. And then negative 9t, the one h cancels, so 9th, and then negative 3h squared. And then we're going to replace the h's with 0 because it's h towards 0. So we have 18 minus 9t squared. When I replace this with 0, this term becomes 0. When I place this with 0, same thing. So this is the formula for the instantaneous velocity. So v of t at a given time is 18 minus 9t squared.